Welcome to another video over the normal distribution. In this video, we're going to talk about the inverse normal function, one of the most helpful functions that you're probably ever going to use, to be honest. It's all over the AP test. All right, here we go. So it is an inverse function. Let's remind you what an inverse function has, right? Like many functions, the normal function also has an inverse. If you haven't, if you're like, the normal function, what's that? Please go back and watch my other video over the normal function. But the normal function, like any other function, has an inverse, simply where the inputs and the outputs are switched. So the inverse normal function works like this. The input of the inverse normal function is a proportion of data that is below a particular z-score. The output value of the inverse normal function is the z-score that has the inputted proportion below it. Sorry, I misspelled inputted there. I did inputted. All right, so here's the idea. The normal function, the input is a range of z-scores. The output is a proportion of data between those two z-scores. The inverse normal function works completely opposite of that. The input is a proportion of data above or below, to be honest. I wrote it below there, but it could be above. It's a proportion of data that is above or below a particular z-score. And the output is that z-score that has that inputted proportion of data below or above it. So on our calculator, the inverse normal function is called invert norm, I-N-V norm. It's right underneath normal CDF, which is our normal function. So keep in mind here, you enter in a proportion below an undetermined z-score, and then the calculator will give you the z-score that has the inputted proportion below it. Sounds a little bit confusing, so let me draw you a quick picture. Okay, here's our normal model with z-scores labeled on the bottom. All right, you hopefully understand all of that. Now, let's just say that I'm saying, I wonder what z-score has 15% below it. I don't know. I don't know. Maybe I'm just kind of spitballing. Maybe somewhere around here where there's 15% of data below it. So I know that there's 15% right here. What I'm trying to find is the z-score that marks that 15% below, or all proportions have two sides, or the 85% above. And that's exactly what this invert norm does. So again, let me actually show you this on the calculator. So second vars is where you get to your distribution menu. And you'll see that right underneath normal CDF, our normal function is the inverse normal function. So click on that. Now notice it says area. That's where you're typing in the proportion, the percentage, the probability. It's an area, right? The entire curve represents an area of 100%. And we're looking for a specific area. And we're looking for that bottom 15%. So I'm going to type in 0.15. And then I just need to make sure I have left selected here, because that's 15% to the left, 15% below. Now, I could type in 0.85 and then select right, because if I have 15% below, I have 85% above. Now, if you have a calculator that does not have this row right here for tail, and you're like, well, wait a minute, I don't have an option for left, center, or right. Well, then unfortunately, you have to type in the proportion or the area below. You don't have a choice. You got to go below. Now, I'm going to be honest. I always do below. I always leave it on left, and I always think about the below. That way, I'm helping out anybody that has that calculator that doesn't have these options. So anyway, the point is I'm inputting the proportion to the left, below, and the output is the z-score. So the z-score that has 15% below it, 85% above it, is negative 1.036. Now, I got to be honest, my picture wasn't drawn great. Maybe it should be like moved over a little bit. But again, I was just kind of spitballing. I was just kind of pretending because I didn't know was the point. I didn't know what the z-score was, but now I do. So once again, that's the idea here. I gave it the 15% below. It gave me the z-score that has the 15% below it. But don't ever forget about the fact that there's 85% above it. All right, so let's do another example here. So here we're looking at what z-score, and again, this says less than, that's the less than sign pointed left, what z-score has 45% below it. So I know that I want 45% to the left. But the question is what's the z-score that has 45% to the left? And that's exactly what you're going to do. You're just going to go right to your calculator, invert norm here, and you're going to type in 0.45. This is the z-score that has 45%. Whoa, I typed the wrong thing. I am so sorry. I hit invert t. You're not going to learn about that for a while. Invert norm here, number 3. I apologize. Again, the area below is 0.45. That's the area to the left. That also simultaneously means 55% to the right. You're more than welcome to select right and type in 0.55. But for those of you that don't have that option on your calculator, you have to type in the bottom 45%. And I get that z-score, negative 0.126. So that's the z-score. The z-score is negative 0.126. That's the z-score that has 45% below it. Now, what about this next question here? This one says we're looking for the proportion, the z-score that's greater than what? We don't know what the z-score is, but we do know that there's 15% above. So we're looking for the z-score that has 15% above it, greater than. That simultaneously means 85% below. So once again, this is exactly what invert norm is going to do because I don't know the z-score, but I do know that I have 85% to the left. Once again, I could type in right, and then I would type in 0.15. It's up to you. Unless you don't have the option for the tail, then you have to look at the bottom 85% in this case. All right, and I'm going to get the z-score, 1.036. So a z-score of positive 1.036 has 15% greater than it, simultaneously 85% below it. Easy, easy, easy. All right, how about we try some examples right now? Let's look at this first one. We're trying to find a z-score that has 95% below it, less than points to the left, so 95% below. So fast and simple. Invert norm, not invert t like I've already done once. Put 0.95 below. Obviously, I'll say this for the 4th time. I could do 0.05. That'd be the 5% to the right, but I'm always going to stick with left. And I get the z-score 1.645. So a z-score of 1.645 has 95% below it. All right, let's do number 14 right underneath it. This one is greater than, so we're looking for a z-score that has 25% greater than it. This would actually be the 3rd quartile, right? Because the 3rd quartile has 25% to the right, 75% to the left. So this is asking me to technically find the z-score 3rd quartile. All right, so once again, I'm just going to go to my calculator here. Invert norm. Again, I need lower. I need bottom. So I'm going to do 0.75 to the left. Again, you could type in 0.25. You would just have to select right. You would get the same answer, I promise. 0.67. Hold on, I got to look at that again. 0.674. Yes, if I round to 3 decimals. So a z-score of 0.674 has 25% above it, 75% below it. Why don't you try these next two on your own? Hit pause, and then as soon as you hit play, you'll see the answers pop up. And boom, there's our answers. So the z-score that has 12% below it, in turn 88% above it, is negative 1.175. And the z-score that has 70% greater than it, which would be 30% less than it, is negative 0.524. Easy, I hope. All right, now let's look at an actual context problem here, a problem that actually has something in it, not just random z-scores. So the weight of female tortoises on a Galapagos Islands follows a normal distribution. Boy, oh boy, that is so important. You can't overlook how important that is, because if it didn't tell me it's normal, I can't do anything I'm about to do. Now, it does tell me that the mean is 250 pounds, and the standard deviation is 22.4 pounds. All right. What weight would mark a female tortoise at the 80th percentile? So remember, an 80th percentile means that there's 80% below to the left. Now that simultaneously means 20% is to the right. I don't care if you use left or right. If you have the option on your calculator, you can use either one. But if you don't have the option on your calculator, you got to go with the left or the below. All right, so let's see here. Now, I don't know the weight of this turtle, but because I have this awesome command on my calculator, I can find the z-score for this turtle. All right, so the z-score that has 80% below it, let's see here, 0.8, select left, or you could do 0.2 and select right. I hope you get, I'm tired of saying that, I hope you guys get it, is 0.842. Okay, now here's the kicker though. Here's why I'm not done. The question didn't say find the z-score. The question said find the weight of this turtle. So what I now need to do is use my z-score formula. The formula for a z-score is a particular value that I'm trying to find right now, minus the mean of 250, divided by the standard deviation of 22.4. So notice that this is truly an inverse problem of what we typically do with a normal function. This time, we know the z-score. We don't know the x that represents it. So what we could do is solve. How cool is this, right? I know the z-score based on using the inverse function and knowing 80% is below it. And now I can actually solve for the weight. You can even put a w here or a t there. Whatever you want to put there that represents you're trying to actually solve for the turtle weight, that would have this corresponding z-score. All right, order of operations. First thing I'm going to do is get rid of division by multiplying both sides by 22.4. So I'm going to take the 0.842 and multiply it by 22.4. I'm going to wait 1 second to actually do that math. And then the next step to solve for the weight would be to add 250 to both sides. And that's what I'm now going to go to my calculator. 0.842 times the 22.4. Add the 250 would be 268.861 pounds. 268.861 pounds. So that would be the actual weight of a turtle that has 80% of all other female tortoises below it, 20% above it. All right, let's do one more here. What weight would mark a female tortoise at the top 5%? That's 5% to the right, 95% to the left. If you have the option on your calculator to select left or right, then you could use either one. For everybody else, we got to go with the left, the below. All right, so the first thing I'm going to do is find the z-score that has 5% above it, 95% below it. Here I go. How quick, I mean, this is just so quick to do, right? There we go, 0.95 left or 0.05 right, it's the same thing. And I get 1.645. But again, that's a z-score. I didn't ask the z-score, I asked to find the weight. Oh, whoa, wait a minute, that's what a z-score formula does. The weight minus the mean divided by the standard deviation will give me that z-score, but I know that z-score, so I can work backwards to solve. Multiply both sides by 22.4. So that's 1.645 times 22.4. I'm going to wait and do that math in 1 second. I like to do all the algebra first, then my math at the end. Then I'm going to add the 250 over. Grab your calculator, 1.645, multiply by 22.4 first, then add the 250, and you get a turtle weighing 286.848 pounds is a turtle that would have 5% of turtles above it, 95% turtles below it. This would be a pretty big female tortoise. It's measuring that top 5%. All right, that's how the inverse normal function works. It's so easy. All you got to do is know how to use it. All right, hopefully this video helped.